All right, let's solve this quickly for those who were struggling a little bit. Negative 9.8 goes in for the acceleration. The distance is positive 2.5. The initial vertical velocity is this component, not 0. It's 8 times the sine of theta. That's you have to have the unknown in there somewhere, right? So 8 sine theta, and I'm not keeping track of sig figs right now, squared. So rearrange this algebraically, and I get negative 8 sine theta, quantity squared, equals negative 2 times 9.8. I just pulled out the negative to make it obvious. So what happens to the negative? They cancel, yep, so you could just go like that. What's the easiest way to solve for theta here? Agreed. I would square root both sides at this point. Okay? So the square root of whatever squared is just whatever. Does that make sense? Okay. The square root of 2 times 9.8 times 2.5. If it were me at this point, I'd put this in decimal form, divide out by 8, and then take the inverse sign. Got it? When you see that, you have to inverse it to get the answer for the angle. Is that enough, or do you need me to go through the algebra beyond this? Everybody okay? All right. Let's do the pickle question. A 45 kilogram crate of pickle relish is lifted up 13 meters from the ground. Okay, go ahead.
Couldn't you have used that sequence one half? That's what I did.
Yeah, except for wowie zowie, it's a huge amount of work because you're going to end up with this is the 2.5, right? Negative 9.8 goes here. Do we know time in the air? What's the initial velocity? Not just 8. So,
yeah, I solved for time first, and then I solved for that.
How'd you solve for time?
The VF minus V0.
Acceleration equals final minus initial over time? This is a valid approach, by the way. No, you can do this. Drew did this as well, but this also will give you an expression that's algebraic. Okay, let's put the numbers in. Negative 9.8 goes here, right? Final velocity at the peak of flight, 0, right? Initial velocity is still 8 sine theta, and then over t. So yes, you can combine these two equations because you have the same unknowns. You have this 8 sine theta here, and you also have t, but it is messy. You didn't do that, did you?
No. We got lucky.
Okay. Did you somehow solve this for t?
I did the acceleration equals negative 8 minus 8 over t, and then I got t, and then I divided it by 2, and then I put it in.
I just used that sequence one half at squared, and then for the initial velocity I put in 0. I don't know why, and then I got this time, and somehow.
You must have just been close enough on the time. Yeah. Drew did the same thing and got close enough. This is a valid approach. You just made up numbers for this part, right? Yeah. Yeah, you're in good company, Drew. All right. Okay. All right, let's do the pickle relish one. So we're lifting up this crate. We're lifting up this crate, and you're trying to figure out the tension in the rope. That's what's happening. This is an F equals MA problem. Yeah?
Okay, so is tension the same thing as force?
Yeah. Yep, no problem. That'd be good to know, right? Yeah, okay. Yeah, tension is another way to say force when we're talking about like ropes, chains, cables, strings, because those types of objects only have tensile strength when a force is applied to them. Do we care about this, or are you just trusting me that T equals F? It's because you can't push a rope. Anybody ever heard that expression? No. Yeah, you can't push a rope. What happens if you push a rope or a chain or a string? Or, it bends. It just wiggles around. You can't, because it doesn't have tensile strength on its own. Tensile strength is, in other words, not rigid, right? It's a solid, but it's not a rigid solid, like a fluid solid. Okay, anyways. So you can only do rope tension, and the reason we call it that is because you can only pull those objects. You can't really compress them or push them, but it's still just like that. Okay. So we're going to lift this thing up 13 meters off the ground. So initially, when it's on the ground, what's the speed? 0. So it has an initial velocity of 0 and a final velocity at the top of the 13 meters of something. We don't know. We know the height. Of course, we have to overcome gravity, right? Okay. And then what tension should be used here, that's going to be an F equals ma. So besides tension, is there any other force acting on the pickle crate? Gravity. How do I calculate the gravitational force / weight of the object? Ma, right. 45 kilograms times 9.8. So the weight is pulling down that, Herschel, that equals 450-ish newtons to be exact, or 41, thank you. So the weight is 441 newtons. Should T be greater than, less than, or equal to 441? Greater. You got to overcome the weight, right? If I pull at 441 exactly, what am I going to do? Nothing. I'm just going to tension the rope to 441, but it's not going to lift the crate, right? So we know that T has to be greater than 441. How much greater will be reflected in the conditions of the lifting over here, this part, the kinematics part. So if I lift with 1,000 newtons, I'm going to cover this 13 meters pretty quickly, right? But if I only lift with 442 newtons, will I still be able to lift 13 meters? Yeah. Yes. Just take longer. And were you given the time it takes? Why, yes, you were. Okay, so I know conceptually you see the link between those things, right? Now, how do you get there? Yeah. There's two different problems. There's F equals ma. That's just these two forces equals 45a. And then there's what's happening over here in the kinematics world. So could you figure the acceleration, the lifting acceleration, if you knew stuff about the final and initial velocity and the distance traveled and the time it took? Initial, final, distance, time. Initial, final, distance, time. With acceleration?
I think it's the last one.
We might be able to do it here. Don't have a time factor here, yeah. And we don't know we know the initial velocity is 0, but you don't know this or this. That would have been the easiest way to do it. What else could you do? That one? What's the distance? 13 meters. What's that? A, that's what we're solving for. Gravity's in here, but we're taking that into account with the weight. What's the time? 4 seconds. What's the initial velocity? 0. So that whole expression will, oh yeah, we could do this. Let's do that. Yeah, this one wasn't too bad. You just had to have the vision to see that you had, this is a complicated two-step problem. The first step is the kinematics. The second step is the F equals ma. So we said this part is 0. The distance is 13 meters. The acceleration is what we're solving for, and the time in the air is 4 seconds. So just solve that for acceleration, and you will get 1.625, we're keeping extra sig figs around, meters per second squared. Okay? Now come back over here and do F equals ma. What are the two forces acting on the Fickle-Crate? Gravity and tension. Which one wins? So I'm going to make tension positive and gravity negative. Also makes sense given the direction of motion, right? T is the positive direction, gravity is the negative direction. So that's the force side. How much mass? Is the mass 45 or 441? Good, right. Thank you, Jerome. Mass! That was actually helpful, right? And the acceleration? Yeah. Could you solve that for T? Yeah. How many sig figs should you have in your answer? Two, good. Yeah, I get 514.125 newtons. 2 sig figs rounds to? Yes. Alex, did you have honors time last year? No, so you don't know what I'm talking about when I'm saying sig figs, do you? Okay. Kind of know? Okay.